You know that moment when you paste your error into an AI, it gives you a confident fix, you apply it, and somehow, things get worse? Yeah, we've all been there. But here's what's interesting. That frustration you felt isn't just a skill issue. It's actually pointing at something much deeper about how these AI systems work. And once you understand it, a lot of things start making sense. Let me tell you about something that happened recently at Amazon. Their retail website, one of the highest traffic platforms on the planet, suffered 4 high-severity outages in a single week. The checkout button stopped working. Parts of the site went dark for hours. And the root cause? An engineer followed a fix suggested by an AI agent, one that had pulled information from an outdated internal wiki. Now look, I'm not here to dunk on Amazon or on AI. Humans make mistakes too, and one incident doesn't write off an entire technology. But here's what stood out to me. This is the same company pouring hundreds of billions into AI infrastructure. And when things broke, their solution was to put more humans back into the loop. That made me ask a question I haven't been able to shake since. If AI is supposedly so good at writing code, why does it keep breaking things when it touches real systems? There's actually data on this now. Scale AI released a benchmark called SWE Pro. It tested AI on real software engineering tasks, not toy problems, but actual work inside production-grade codebases. The kind you inherit at a real job, full of weird decisions, legacy code, and that one service nobody wants to touch. The best models from OpenAI and Anthropic solved around 20 to 30% of the tasks. And this is the part most people skip over. It's not just a context problem. There are real, structural limits baked into how these systems work. Let's actually talk about them. When you're working inside a large codebase, you carry a mental model in your head. You know why that weird workaround exists. You know which files are load-bearing walls. You know that touching one service somehow breaks 3 others. The AI doesn't have that model. It sees tokens, patterns it's encountered somewhere before. So it generates code that looks completely right, but quietly violates the one constraint you forgot to mention in the prompt. Researchers at MIT actually studied why this happens. Inside these models, concepts are compressed into high-dimensional spaces, but there isn't enough room to represent everything cleanly. Ideas start overlapping, stacking on top of each other. The model can recognize surface patterns, but it loses the deeper structure behind them. It's like trying to tune into 5 radio stations on the same frequency. You get noise that sounds like music. Okay, so here's where it gets a little wild. You know how when you're deep in a debugging session, like 20 files open, scrolling through logs, cross-referencing 3 different services, and you paste all of that into an AI and it just loses the plot halfway through? That's not a coincidence. There's actual math behind why that happens. The way these models process information, it's called attention. Every single token has to check itself against every other token in the conversation. Sounds fine, right? Until you realize the cost of doing that doesn't grow linearly. It grows with the square of how much context you give it. So double the context. 4 times the compute. Triple it. 9 times. At some point the model either costs a fortune to run, or it just starts quietly dropping things from memory mid-task. Like that one friend who forgets what the conversation was even about by the time they respond. And that's why complex debugging still breaks AI tools. Not because the AI is being lazy. It's literally physics. Alright, this next one. I genuinely think not enough people talk about this. Imagine you hire an assistant. Smart, fast, gets things done. But there's one catch. They cannot tell the difference between you giving them instructions and a random note someone slipped onto their desk. That's basically what's happening with AI agents right now. To a language model, everything is just text. Your prompt, a web page it's reading, a file it's summarizing, a user message, it all looks the same. Same tokens, same math, no labels that say this is a command or this is just data. Here's something that I think is genuinely underrated as a concern. Look around the internet right now. Blog posts, tutorials, Stack Overflow answers, GitHub threads, a massive chunk of it is AI generated. And that content is now becoming training data for the next generation of models. So these models are increasingly learning from themselves, from their own outputs, from their own mistakes. Researchers actually have a name for this, model collapse. And the way I think about it is, imagine photocopying a document, then photocopying that copy, then photocopying that copy. Each generation loses a little more sharpness until eventually you just have blur. That's the trajectory if nobody course corrects. Dario Amodei, the CEO of Anthropic, basically said the easy wins from just making models bigger are running out. The era of double the parameters, get a smarter model is fading. We're basically putting a sports car body on the same engine and calling it a new model. It looks faster. It feels faster. But under the hood, not much has changed. Look, I'm not making a AI is useless video. I use it every single day and it genuinely saves me hours. But there's a version of this conversation that nobody's having honestly. AI is incredible at the first draft. Seriously. Scaffold a feature, explain a concept, unblock yourself at 2 a.m. when no one else is awake. It's genuinely great at that. What it's bad at? Knowing when it's wrong. It won't tell you, hey, this solution looks right but it's going to collapse under load. It won't sense the architectural constraint you didn't mention. It will confidently give you something broken and you won't know until prod blows up. So the skill that actually matters in the next few years isn't just writing code. It's having enough understanding to catch the AI when it's confidently wrong. Because it will be confidently wrong. Regularly. The developers who build that foundation? They're going to be fine. The ones who just vibe code everything and trust the output blindly. That's where it gets risky. These models will keep getting better. The tooling will improve. But the structural cracks we talked about today aren't getting patched in the next update. They're in the foundation. And that's actually good news for you. Because it means the floor hasn't dropped out from under developers. It just means the job description is shifting. Anyway, I'm curious. Where has AI actually burned you in a real project? Drop it in the comments. I genuinely read them. And if this video made something click, you already know what to do.